Okay guys, in this one here I've got a true or false, and so we got to kind of try to make up our minds, but the idea is going to be that we're very familiar with the domains and ranges of our inverse trig functions here. So some things like, recall that when we use our arcsine function here, it always kind of gives us back an angle between positive 90 and negative 90. So is these values here in quadrants 1 or 4, but because we hit all of our positive sign ratios, right, up in the first quadrant, all of our positive y sign ratios, and all of our negative sign ratios in this fourth quadrant right here. When it comes to cosine inverse, recall that we hit all of our positive cosine values in this first quadrant here, so from all the way from positive 1, right, all the way over to negative 1 by proceeding through quadrants 1 and 2. So cosine inverse is always giving us back angles between 0 and 180. And then tangent inverse, we like to know that it always gives us back angles between negative and positive 90 as well, because if we do y over x at each of these stops in the first quadrant here, we're going to hit all of our positive tangent ratios. But if we do y over x down here in the fourth quadrant, we get the same numbers back. We just get their opposites, their negatives, okay? So looking at this true or false here, let's start with this first part. It says if sine of 5 pi 6 is equal to a half, then is the arcsine of a half equal to 5 pi 6? Excuse me, and this goes back to the heart of these relationships here. The idea is that if I have 5 pi 6 and I take the sine, okay, of my angle, then I get sine of 5 pi 6, and that equals a half. And that's easy to show here. We can just go look at our unit circle. 5 pi 6 would be a pi 6 short of 6 pi 6. So you can see our sine value is indeed a half here. But as we turn around and look at this again, we say, well, then does that mean that if I put this into arcsine, right, our sine inverse function here, and I should say of our ratio, okay, would I get back to the same angle I started with? And that's the primary argument here. So we've got to be very, very careful, remembering things like arcsine always gives us back an angle between negative and positive 90. So really when I say what is the arcsine of a half, I'm kind of saying, looking at this unit circle here, what angle between positive 90 and negative 90 gives me a sine value that is positive a half? I only see it right here, okay? And that angle, if we were going to give it a name, is 30 degrees or pi 6th, and not 5 pi 6th, okay? So in this case here, we're not supposed to get 5 pi 6th. The arcsine, okay, the arcsine of a half would only just be a positive 30 degrees or positive pi 6th. And so in terms of what I would want to write here, well, in this particular instance, I have to say false. It's not always false. But the reason why I am going to say false here is because when we look at the arcsine of a half, okay, the only acceptable set of outputs is between positive and negative 90. And so if we're taking the arcsine of a half here and we're trying to say, do we get 5 pi 6, it's just not possible because 5 pi 6 is not between positive and negative 90 here. So, to put this in words, because I do have to explain my reasoning here, as soon as this shows up here, the range of arcsine is negative 90 degrees to positive 90 degrees, okay? And I know I'm doing this in degrees here, so maybe I should say from negative pi halves to positive pi halves. The fact is that 5 pi 6 is not in that range, so the angle 5 pi divided by 6 is not in the range of arcsine, okay? We probably ought to state here also what the arcsine of a half should be equal to. So the arcsine of a half should be equal to pi 6th or 30 degrees, okay? So, if this up here, if I had started with, say, for instance, sine of pi 6th, just throwing this out there, if we had said to begin with, the sine of pi 6th equals a half, so is this true? The arcsine of a half equals pi 6th. This would have been totally okay because this is an angle between negative and positive 90 that gives us a sine of a half, and that would have been within the acceptable range. So be on your toes with respect to questions like this regarding domain and range of inverse trig functions. Cheers.